Hello everyone. My name is Yinghua Zhu. Today my topic is the strength of the trade soil. With the development of a human social, the building environment, including construction, installed hair wells, construct and impact of the diamond has increased dramatically to the unacceptable level. However, due to its natural morning source are not suitable for building foundation. It has a lower composite and texture strength. Cause a larger sediment of the foundation. Although where the diameter technology are used to drama the sustainability and of the larger segment and increase the strength and strength. Due to limitation of the time and cost, it will not accept of the some case. So, and most private solution, the problem is adding the chemicals including segment, lignite, fire ash, bitumen, chemicals compound and to increase the composite of the strength of the soil. The sediment of the soil can be divided into the three parts, include limiter, load per pad, concentration set, and the second compartment. Due to the loading added to it, the second compartment will be loaded of the until permits. Consolidation completes their two main steps to analysis the segment of the soil by the number of the mass, either including the stress increment in the soil by the load and the operate strength relationship of the soil by the ordinate test. The soil knows the probably material for the foundation due to the its poor compressive strength can be solution by the camp's material adding. However, the concept of the performer of the trade solution on the application node need to the define of the initial prevent for the segment coordination. Therefore, in the order of demand of set of the under the geography process of geography energy field, the report will be invested of the compression behavior of the trade. Soil which is treated by the segment. Soil segment not the opponent comment what as soil max material gain of the improvement of the strength and the material quality of the oil, the soil.
Thanks for Drew's speech. Now let me show you about what our group have learned and discovered. Through the ion-confined compression test program, a research evaluated the effects of materials content, porosity, shaping, moisture content, water cement ratio. The experiment is divided into three parts. Firstly, the characteristics of soils are described. Next, measure the amount of lime and cement, and then a series of unconfined compression tests were carried out. Finally, a series of conclusions are drawn. In finding one is a research about the effect of cementing material on the mechanical strength of soil. As a result, the decrease of porosity will have obvious influence on the increase of unconfined compressive strength. This However, as the porosity decreases, the porosity of the soil cement mixture increases exponentially, while that of lime mixture increases linearly. The first figure shows the results. A line of unconfined compressive strength test at the meeting point. Unconfined compressive strength Qu changes with the content of cementing materials. South-lime relationship is linear, so cement-soil relationship is power fiction. So the indicates that reducing porosity is more effective in salt cement mixture than in salt lime mixtures. The finding two is the effect of molding moisture content on unconfined compressive strength. As a result, under the condition of keeping drawback density unchanged, changing water content has little effect on unconfined compressive strength of mixture. The finding three is about the variation of unconfined compressive strength with adjusted proportive volume track content of cementing agent. As a result, the linear expressions fit well the relationship between unconfined compressive strength and adjusted line proportive volume content, while power friction are more suitable for cement. The research also found that after taking the salt lime mixture parameter to the power of 0.06, the cement salt mixture parameter to the power of 0.35, and making good adjustments to the unconfined compressive strength data, a good consistency was obtained. The finding four is about the influence of cement content, porosity, and pore water cement ratio on the mechanical strength of fiber reinforced cemented soil by splitting the tensile and unconfined compression test schemes. As a result, unresisted compressive strength is positively correlated with the change of cement content, and with the decrease of porosity, the unconfined compressive strength gain rate of salt cement mixture increased significantly. Through the experiments, the research found that unconfined compressive strength varies linearly with the cement content. The straight line perfectly conforms to the QU to C relationship. In addition, with the decreased porosity, the unconfined compressive strength gain rate of soil cement mixture increased significantly. The finding 5 is about the effect of lime content, porosity, weight-age lime ratio on the mechanical strength and initial straightness of lime stabilized clay sand by unconfined compression test scheme. As a result, the unconfined compressive strength increase approximately in with the increase of lime content. The unconfined compressive strength increase with the decrease of the porosity. Through the content shown by the above data, our team has a clearer understanding of the progressing method of strength of treated salts in various situations. Now I'd like to invite another member of our group to continue the following speech. Thank you.
Now let me talk about the analysis of our report. In order to determine the unconfined compressive strength QU, this research will be using the numerical method by the function of relationship between QU, porosity, and volumetric cement content. The equation shows in the screen. Porosity refers to the ratio of the volume of voids to the total volume of the soil. According to the definition of the void ratio of the volume of voids to the volume of solids, the porosity equation can be defined as in order to investigate the impacts of the porosity, this research obtains the experimental value from the Moria research. The relationship between the porosity of unconfined compressive strings has been defined in the figure for the sample with 6% of the cement. In order to investigate the impacts of the porosity, this research obtains the experimental value from the Moria research. The relationship between the cement contents and the UCS has been defined in the equation below. The relationship between the UCS and the porosity cement ratio by using the equation. The experimental data took from the past experiment done by Sarah etc. According to the Excel sheet, best fit curve can be found in the equation as the follows. Therefore, for the soil mixture with the cement, this equation can use the unconfined compressive strength calculation and prediction. Now let me talk about contributions. Actually, all of our team members tried their best to do this project. Considering the complexity of completing the project, we assign our respective tasks. Yinhua Zhu is responsible for consulting the literature to find the literature suitable for our project. The task Xinzhou is to sort out the relevant literature. Finally, Hong Zhetian's task is to calculate the data and draw conclusion. In order to use this result presented by the study into the application of geological practice, an example has been described as follows. A sample taken from UCS with the result of the QU equal 2000 kPa. This unconfined compressive strength can be mixed with various contents of the cement in order to establish the different options for the cement content combination of to reach the 2000 kPa unconfined compressive strength. The porosity cement ratio need to be defined. The total dry mass samples equals to the dry soil mass and cement. The dry mass of the test sample can be calculated by the specific dry weight, the volume of the sample, and the dry mass of the soil by using the equation. The value of the volumetric cement content can be calculated by the equation. Thus, two options can be generated by the calculations. Option 1, 5% of the cement content for reaching the requirement of the unconfined compressive strength with the porosity cement ratio is 29. The dry unit weight for this option is 17. Option 2, 7% of the cement content for reaching the requirements of the unconfined compressive strength with dry unit weight of 16.4. According to the result of the options, buildings can choose the option depending on the project requirements. In any case, this method could provide a range of the options for the project selection and according to the requirements of client and Australian standard. That's all. Thank you.